Good morning, friends. So we are studying sharing stresses. So that's why today also I am continuing sharing stresses. So this is today's last lectures for sharing stresses. So in the next class we can start fifth unit. So for different sections today we'll see, and that section is the C sections and unequal I section. So please note down today's first problem.
A beam of channel section (120 mm by 60 mm) has uniform thickness
of
15 mm.
Draw diagram showing the
Draw a diagram showing the distributions of shear stress
for a vertical section
for a vertical
C section
C section
where shearing force is
where shear force is
60 kilonewton find
the ratio between
maximum
and mean shear stress. So this is C section. So this is symmetrical about neutral axis or XX axis. This is 60, this is 15, this is also 15, and this is total 120. So that's why this is 60 and this is 45.
Now this is
Symmetrical about neutral axis, and this hollow portions also passing through the this neutral axis. So that's why YC equal to YT will keep this space for distribution sum of the shear stress diagram, because this is shear stress above, this is below, this is maximum shear stress, same here also.
So please here YC equal to YT equal to, this is YC equal to YT equal to, because this is symmetrical. So that's why this is 60 mm
Now moment of inertia about x axis equal to, so we can take this is capital BD cube or otherwise 1 divided by 12 capital BD cube small BD cube. So capital B means this is solid and this is solid and this is hollow. So solid equal to capital B equal to 60, D equal to, you can consider this is 120 cube, small b this is 45 and this is 90 cube. And this is moment of inertia and this is mm raised to 4. So that's why this is 60 into 120 cube minus 45 into 90 cube and divided by 12. This is 5.906 10 to the power 6. Now we can calculate. Here we require now shear stress first. Shear stress above the junction of web and flange. So this is junction of web and flange. So here's AY bar equal to (60 into 15 multiplied by) now this distance, centroidal distance, this is Y bar. So this is 60 minus 15 divided by 2. That's why this is 52.5 multiplied by 15 multiplied by 60. 47250. Now SAY bar equal to so this is above equal to SAY bar divided by capital BI. So S equal to what is given 60 kilonewton. So this is 60 multiplied by 1000 into 47250 divided by B equal to 60, and this moment of inertia 5.906 10 to the power 6. So this 60 will get cancel, multiplied by 1000 divided by 10 to the power 6 divided by 5.906, and this is 8 megapascal. So that's why below equal to, now here's divided by, so that's why 8 multiplied by 60 divided by 15, this is multiplied by 4, 32 megapascal. Now shear stress about neutral axis. So AY bar equal to A1 Y1 bar plus A2 Y2 bar. So A1 Y1 bar, we already calculated that. So this is 60 into 15 into 52.5 plus this second area 45 into 15 multiplied by 45 divided by 2. This is 4725 plus
45 multiplied by 15 multiplied by 22.5.
15187
plus 47250
62437. So shear stress about neutral axis equal to SAY bar divided by BI 60 into 1000 multiplied by 62437, B equal to 15, and this is 5.906 10 to the power 6.
So that's why here multiplied by 1000 again multiplied by 60 divided by 15 divided by 10 to the power 6 divided by 5.906 equal to
42.28 megapascal. So this is 32, this is 8 megapascal, and here 42.28 megapascal. Now, so this is maximum. So mean shear stress equal to shear force divided by area. So shear force equal to 60,000, area equal to 120 into 60 minus 45 into 90.
90 into 45 120 into 60 is 4050 advances. So this is equal to 19.40 megapascal, and ratio equal to maximum divided by mean. So maximum equal to, that is 42.28 and divided by 19.047. So this is equal to 2 point something, 2.2197. This ratio equal to, this is your expected answer. So such type of the, if you are familiar, you can solve very fastly problems of the any problems. So try to solve the problems, so don't hesitate. You can solve any problems, only basic concept related with the that subject and the chapters are important, and you can solve any problems. So by solving the problems, your basic concept will be clear. So this is first problem. Now second problem is the unequal eye section. So in unequal if eye section means that you can split into like a type of the solid and hollow, but this is unequal eye section means we have to calculate. A cast iron bracket subjected
A cast iron bracket subjected
So we'll see, because this is I feel this is incomplete problem, because we require shear force. Right, subjected to a
shear force
shear force
100 kilonewton
of
has a
cross sections
section of I section with unequal
flanges
as shown in figure. Draw its shear stress distribution diagram. So in these problems, and this is unequalized section. So for where is the abrupt change of the cross sections, there you will get different shear stress distribution diagram. This is 150, this is 250, this is 50, This is 50. This is 50. And this is total 350. So that's why this is 250. So here's I think so this is different. Suppose this is neutral axis. So here's this is maximum. So for this problem, this is symmetrical about x axis, but this is symmetrical about y axis, but unsymmetrical about x axis. So that's why we have to first calculate. This is reference line, and this is YC. This is YT. You can say this is YC, YT. Otherwise, this is yes. So YC equal to A1, Y1, A2, Y2, A3, Y3, A1 plus A2 plus A3. So area of the first component. This is 250 into 50. Y1, this is 25. So this distance is the Y1. Now plus area of the second component, 250 into 50 into Y2. So this centroid here and this distance. So this is 250 divided by 2 plus 50. Plus. Now this is 150 into 50. This is 50 plus 250 plus 50 divided by 2. So this is understanding purpose. I will update this. Now area, this is 1, this is 2 and this is 3. 250 into 50, 250 into 50 and plus YC equal to. So this 25, 25, 125, 0, 125, 0, 15, 15, 75. So this is 1250 multiplied by 25. So into 175. So this is 12,500, 25,000, 32,500 plus 2187, sorry, 50 plus 313. 250 divided by, this is 151.92, right, this is 151.92 mm, and yt equal to minus 350, 198 mm. So try to understand this. So next portion is the calculations about the moment of inertia. For moment of inertia, here formula, first self moment of inertia plus a1 y1 square, second plus a2 y2 bar square plus self 3 square. So that's why self moment of inertia, first self moment of inertia. Now B equal to 250 and D equal to 50 cube divided by 12 plus first area 250 into 50. Now centroidal distance, so this is 151.92 minus 50 divided by 2, because this distance. So this is y1 bar plus 250 into 50 cube, again plus, now 250 into 50, so this is 250 divided by 2 plus 50 minus 151.92, right, alright, plus 150 into 50 cube divided by 12, this is also divided by 12, and plus 150 into 50 into, now this distance total 198 minus 50 divided by 2 bracket square, here also bracket square. So in this problem, moment of inertia is very important. 250 into 50 cube divided by 12. This is equal to 2.6 into 10 to the power 6. Next, 151.92 minus 25 square multiplied by 250 multiplied by 50. This is equal to 1 201.35 10 to the power 6 plus again 250. Okay, sorry, because here this is 50, second 50, and this is 250. So make correction. B equal to, because this is 50 and depth equal to 250. (65) 10 to the power 6 plus 125, 175 minus 151, 92 square multiplied by 250, 6.658. And 50 into 1.562 10 to the power 6, 198 minus 25 and square multiplied by 150, 224.46 10 to the power 6. Plus 2.6 plus 65.1 plus plus 6.658 plus 562 501 1.75 10 to the power 6. Now, so briefly, now I am writing this is above. So that's why SAY bar divided by capital BI. So S equal to AY bar, A equal to 250 into 50 into Y bar distance, that is 151.92 minus 50 divided by 2 divided by B equal to 250 I 75 10 to the power 6. So this 250 will get cancelled. 1 divided by answers. Multiplied by, and this is 126.92 multiplied by 50 multiplied by, this is equal to 1.264 megapascal. Once again I will check.
151.92 minus 25 multiplied by 50 multiplied by divided by 10 to the power 6 divided by 1.264, right. So this is above and this is below of top flange of top wave. And this is below, and this is 1.264. So here this is multiplied by 250 and divided by 50, means multiplied by only 5, 6.323 mega Pascal. Now this is about neutral axis. So here again this is same. In bracket 250 into 50, 126.92 plus area. Now this area 50 into, this is 151.92 means 92 multiplied by divided by about neutral axis. So 101.92 square divided by 2 multiplied by 50 plus 250 into 50 into 126.92 multiplied by divided by 50 divided by 501.75. So this is 7.35 mega Pascal. 1.264 mega Pascal. 6.323 mega Pascal, and this is 7.35 mega Pascal. Now we'll see, this is above top of bottom flange. Top of bottom flange means again here's SAY bar divided by BI area. Now this area is to be considered, this is area. This is 198 means minus 50. So that's why 148 multiplied by 50 or 50 into 148 divided by 2, B equal to 50.75 10 to the power 6. 148 square divided by 2 multiplied by 50
multiplied by divided by sorry. So first you'll consider bottom, because we are considering this area is the different. So we are making mistake here. Below of bottom branch multiplied by 150 into 50 into 198 minus 50 divided by 2. This is correct. This is 5.17 mega Pascal. And that is, so this is right, 5.17 mega Pascal. Now this is above of bottom planche. This is equal to 150 divided by 50. Sorry, 50 divided by 150. .723 mega Pascal. 1.723 mega pascals. So that's why this is the solution. Now you are understand this whole chapter, shearing stresses. So briefly I take revisions on the distributions of the shear stress diagram for various section. So that's why your basic concept against that will clear.
So for rectangular section,
so distributions, shear stress, distribution for different cross section.
so for rectangular section,
So this distribution sum of the shear stress. So this is max.
for circular section,
Again, this is for hollow rectangular section.
for angle,
And this is angle. So this is toe max. This is above, and this is below. For cross, so this is about, you can say this is about neutral axis, and this is above, and this is below. This is called cross.
for T section, again this is
So this is below, this is above, and this is max. Toe max. Now I section. Above, below, this is below, about neutral axis. For C section,
again similar type.
C section.
So these are the some of the distributions of the shear stress diagram for the different sections. So that's why today I stop here and we complete these chapters, and that is the distributions of the or shear stress distribution. So in the next class we can start the 5th unit. So I think in the 5th unit that chapter is the torsion chapters and column and strut. So that we will study in the next class. Thank you.